Hello everyone, welcome back to our channel. Today we are going to do experiment number 4 of our operating system lab, and the topic is multi-threading. In this video, I will show you what a thread is, why we use multi-threading, how to use POSIX threads, that is P threads in C language, and finally we will write a complete C program with 3 threads. So please watch the full video till the end so that you will not have any doubt. We will cover 5 things today: thread fundamentals, why we need multi-threading, p-thread functions, and a 3-thread programming exercise, and finally compilation and execution. Let us start. Before we go into the topic, let us see what you will learn by the end of this session. First, you will be able to define process, thread, multitasking, and multi-threading. Second, you will understand the difference between a single-threaded process and a multi-threaded process. Third, you will know why threads are faster than processes. Fourth, you will learn how to use the pthreads library in C. Fifth, you will learn 5 important functions: pthread underscore create, pthread underscore exit, pthread underscore join, pthread underscore self, and pthread underscore equal. And sixth, at the end, you yourself will design a program with 3 threads: one for odd numbers, one for even numbers, and one for natural number sum. Okay, now let us go one by one. Let us first understand 3 basic words: process, thread, and multi-threading. Don't worry, it is very simple. Process means a program which is currently running. For example, when you open a browser, that is one process. A process can be divided into small independent units, and these small units are called threads. Thread means a path of execution inside a program. You can say thread is a lightweight worker inside a process. Multi-threading means many threads are running inside the same process at the same time to do multitasking. This gives us parallelism. Now see this diagram. On the left hand side we have a single threaded process. Here only one thread is doing all the work, one after another. On the other side we have a multi-threaded process. Here thread 1, thread 2, and thread 3 all are working together inside the same process. This is the real advantage of multi-threading. Now the question is, why do we need multi-threading at all? Let us see 4 important advantages. Number 1, faster creation. Creating a new thread is much faster than creating a new process. Number 2, faster context switching. Switching from one thread to another thread is faster than switching between processes. Number 3, easy termination. We can stop or terminate a thread very easily. Number 4, faster communication. Because threads share the same memory, they can communicate with each other very fast. Now let us see 2 real-life examples. In your web browser, every tab you open can run as a separate thread. In MS Word, one thread is formatting your text, and at the same time another thread is reading your keyboard input. So the key idea is this: multi-threading improves our application through parallelism and lightweight execution. This means more work is done with less overhead compared to creating separate processes. Now let us come to pthreads, that is POSIX threads. This is a library we are going to use in our C program. First, the header file. We must include pthread_head at the top of our program like this. #include pthread.h. This header file is required to use all the pthread functions. Second, the compiler. We are using GCC compiler, and the good thing is the pthreads implementation is already available with the GCC. You don't need to install anything extra. Third, the core API. That means the main functions we will use pthread underscore create, pthread underscore exit, pthread underscore join, pthread underscore self, and pthread underscore equal. We will see each of these one by one. Now see this real thread lifecycle diagram. Step 1, we create the thread using pthread underscore create. Step 2, the thread runs the function we gave. This is called the start routine. Step 3, the main thread waits for it using pthread underscore join. Step 4, the thread terminates using pthread underscore exit. This is a complete life of a thread. Create, run, wait, and terminate. Please remember this flow. It is very important. Now let us understand the most important function, that is pthread underscore create. See the function signature on the screen. Int pthread underscore create takes 4 parameters. First parameter is thread, a pointer. This will receive the ID of the new thread. Second parameter is attr, thread attributes. If you don't want anything special, we simply give null. Third parameter is start underscore routine. This is a function which thread will execute. Fourth parameter is arg. This is the argument we want to pass into that function. Now an important point. Every thread function must follow the same pattern. Void star function taking void star as parameter. Why void star? Because void pointer is a generic pointer. It can carry any type of data into the thread and out of the thread. Sometimes we need to pass more than one value into the thread function. In that case, the lab document tells us we can create a structure, put all our variables inside that structure, and pass only the pointer of that structure through arg. This is a very common technique. Please remember it for your Viva. Now let us see the remaining 4 pthread functions quickly one by one. Pthread underscore exit. This function terminates the calling thread. Syntax is void pthread underscore exit, taking a void pointer for the return value. Pthread underscore join. This function makes one thread wait for another thread to finish. You can also receive the exit status of that thread. Pthread underscore self. This function simply returns the thread ID of the current calling thread. Pthread underscore equal. This function compares two thread IDs. If both are equal, it returns non-zero value, otherwise it returns 0. These 5 functions create, exit, join, self, and equal. These are more than enough for our lab experiment. Let us move to the next slide. Application of threading. Now, where do we actually use threading in real life? Threading is used widely in many fields, especially in internet-based system. Threading is commonly used for transaction processing. For example, mobile recharge, online money transfer, and banking transactions. All these use multiple threads to process many requests at the same time. Why threading helps here? Because threading divides one big code into small, lightweight parts. This reduces the burden of CPU and memory and helps the task finish its goal faster. See this diagram. One application creates thread 1, thread 2, and thread 3. All 3 threads share the same process resources, that means memory, files, and input output. Everything is shared between threads. This sharing is what makes thread communicate so fast. Okay, now we are coming to our main experiment. Our task is to write a program using 3 threads. Thread 1 is even. This thread will find the sum of even numbers and also store and display the list of even numbers. Thread 2 is odd. This thread will find the sum of odd numbers and store and display the list of odd numbers. Thread 3 is sum n. This thread will find the sum of first n natural numbers. See the small code on the screen. We are declaring an array of pthread underscore t called threads with the size num threads. Then we call pthread underscore create 3 times, one time for even, one time for odd, and one time for sum n. So the expected structure of our program is first create 3 threads, then each thread performs its own calculation, then main function waits using pthread underscore join, and finally we display the results. Let us see the full logic in the next slide. Now let us see the complete flow of our program step by step. This will help you write the program on your own. Step 1, input n. We read the value of n from the user. Create even thread. This thread will calculate sum of even numbers. Create odd thread. This thread will calculate sum of odd numbers. Step 4, create sum n thread. This thread will calculate sum of natural numbers from 1 to n. Step 5, join all 3 threads. Main function will wait for all 3 to finish. Step 6, display sum and list. Finally, we print all the results. Now, please note this important point. This is called the key synchronization point. pthread underscore join makes the main thread wait for each and every worker thread to finish its work before we print the final result. If you don't use the pthread underscore join, our main function might print the result even before the threads finish their calculation, and we will get a wrong output. So this step is very important. Now let us see the complete program. I'll explain it slowly part by part. At the top, we include 3 header files: stdio.h, stdlib.h, and pthread.h. Then we define num threads as 3. We also declare some global variables n, even sum, odd sum, and natural sum. Notice these variables are declared outside the main function. At the top level, why global? Because all 3 threads need to read and update these same variables, so they must be shared common variables. Now see the even functions. It runs a for loop starting from I equal to 2 up to n and increasing I by 2 each time. This way we get only even numbers. We add each value into even sum. After the loop, we print the even sum and then call pthread underscore exit with a null to end the thread. The odd function works exactly the same way, but it starts from I equal to 1, so we get only odd numbers. Please notice both functions follow the same pattern. Void star function name taking void star arg. This is the pattern which pthread underscore create expects. Remember what we discussed 2 slides before. Now let us see the remaining part of the program. The sum n function runs a simple for loop from I equal to 1 up to n, adding every number into natural sum. This gives us the sum of first n natural numbers. Now the main function. First we declare our 3 threads array. Then we ask the user to enter n using printf and scanner. Next we call pthread underscore create 3 times, one for even, one for odd, and one for sum n. At this point, all 3 threads start running at the same time independently. Then we use a for loop calling pthread underscore join for each thread. This makes sure main functions wait until all 3 threads complete their work. Finally, we print the final results, even sum, odd sum and natural sum, and return 0. See the sample output on the right hand side. If we enter n as 5, even sum will be 6, that is 2 plus 4. Odd sum will be 9, that is 1 plus 3 plus 5. And the natural sum will be 15, that is 1 plus 2 plus 3 plus 4 plus 5. Please try this program yourself and check your output matches this. Now let us do a quick revision. This table is very useful for your record and for your Viva preparation. Pthread underscore create. Purpose is to create a new thread. Key information need is thread ID, attribute, start routine and argument. Pthread underscore exit. Purpose is to determine the purpose is to terminate the current thread. Key information needed is the return value pointer. Pthread underscore join. Purpose is to wait for a thread. Key information needed is thread ID and return status location. Pthread underscore self. Purpose is to get the current thread ID. No extra information needed. Pthread underscore equal. Purpose is to compare two threads IDs. Key information needed is T1 and T2. I suggest please pause the video here and write down this table in your lab record. Compilation and term execution. Now the final most exciting part. Let us compile and run our program. Open your terminal and type this command gcc multithreading.c -o multithreading -pthread. Then press enter and run using /multithreading. Now an important doubt many students ask, why do we need -pthread flag? This flag enables the proper POSIX thread support while compiling and linking our program with the GCC. Without this flag, the linker may not find our thread functions and we may get a compilation error. So please don't forget this flag. Once you run the program, it will ask enter n. You type any number, for example 5, and press enter. Then observe all three threads running and check whether even sum, odd sum and natural sum are matching with your own hand calculation. If everything matches, congratulations, your program is working correctly. The lab document also confirms the program executes successfully by creating three threads and each of them completing its own task before the final result is displayed. Okay, we have completed our experiment. Now let us do a quick recap using some important Viva questions. Please try to answer these yourself before checking the answer in your record. What is a thread and how is it related to a process? Why threads are generally faster than processes? What is the purpose of pthread underscore create function? What does pthread underscore join function do? Why is pthread.h header file required? What is returned by pthread underscore self function? How would you pass multiple values into a thread function? Why must the main thread join the worker threads before displaying the final results? I request you please try to answer all these 8 questions in your own words. This will help you a lot during your lab Viva examination. So that's all for today's experiment. Let us remember the 4 important words of multithreading: create, execute, synchronize and join. Our main takeaway is this: a multi-threaded program divides the work into small, lightweight execution units and coordinates all of them using a pthread SPA. I hope this video was useful and easy to understand for you. If you liked this video, please give a thumbs up, share this with your classmates and subscribe to our channel for more operating system lab experiments. Thank you very much for watching and I will see you in next experiment. Until then, keep practicing and take care. Bye bye.